Okay, now let us continue general characteristics of concrete dams. Until now, we have seen general characteristics of embankment dam for earth fill dam and rock fill dam. Now let us see for concrete dam. So general characteristics of concrete dams. I hope you know the properties of concrete. Already you have seen in different courses like construction material, reinforced concrete design, etc. So concrete by its nature, hard and non-yielding and rigid structures. So concrete dams are just hard, non-yielding and rigid structures because it is made of RCC structure and also high grade concrete. So that's why non-yielding and rigid structures. And the loads are transmitted through the dam body into the foundation. Since it is just a heavy weight, so the load will be distributed to the foundation. So you need what? Sound or good geology, good subsurface geology, and also to dam body also distributed. So you need sound abutment and sound foundation geology. So it requires strong and more or less uniform rock foundation. So the foundation must be uniform or consistent. Otherwise, if it may vary, if it varies from some distance to another, then it may fail or differential settlement may happen. So we need what? Uniform foundation, uniform rock foundation, and also sound foundation, sound, and also abutment. So advantages of concrete dams. So it is good. All concrete dams, either gravity dam or arch dam or buttress dam, you need what? Good, just advantages, good for narrow valley. So it is convenient for narrow valley. If the valley is wide, for one thing, economy, problem of economy. So except arc or cupola, also suitable for wide valley. Otherwise, for gravity dam, arch dam, etc., you need what? Narrow valley. Narrow valley. Okay, smaller construction field volume. This is also advantage compared to embankment, because in embankment you need what? Huge transportation field material. But for concrete dam, since it is narrow, smaller construction field volume, and also construction can take place irrespective of weather condition. So during rain season, you can just proceed your construction. After rain, no problem. Just but for earth fill dam or rock fill dam, you cannot proceed construction after rain. If rain is falling just with high intensity, then the surrounding or the area, the project area, could not be just convenient for transportation, or vehicles cannot move from one place to the another. So construction can take place irrespective of weather conditions since it is concrete. And smaller freeboard. Freeboard also very small, 1 to 1.5 meter, and can be constructed as overflow dam. So if excess flood come, it can overtop. No problem of erosion on the structure. Outlet, pipework, valves, and other ancillary structures also can be provided or incorporated within the body of the dam. So this is also another advantage. But the disadvantage of concrete dams, sensitive to settlement, heavy weight, sensitive to settlement, so demanding what? Sound rock foundation. As I have said earlier, you need what? Sound rock foundation. So sensitive to settlement and sensitive by earthquake. If there is earthquake shocking, either horizontal earthquake acceleration or vertical, so it is sensitive. So crack may happen. So you need to provide what? Very strong foundation. It needs technical personnel, machine requirement, formwork also. So you need sophisticated machines, heavy duty equipments, and also formworks. So compared to embankment, you need what? Machine requirement, technical personnel, engineers, supervisors, highly qualified, and also formwork, sophisticated formworks, and also difficult, dam heightening, difficult. It's also one disadvantage. Dam height could not be easily increased. So you need what? Unless otherwise pre-stressing or anchorage will be done. Otherwise, you cannot increase the dam height. But interference to the landscape. So landscape also, it could not be compatible since the area is just ground or rock or just some geology, earth material. So concrete and earth may not be compatible. So body interference to the natural landscape and completed unit cost are much higher than for embankment fields. So for 1 meter cube concrete, if you compare 1 meter cube concrete and 1 meter cube earth fill, concrete high because a mixture of cement, sand, aggregate, including RCC or reinforcement bars. So high. Completed unit cost will be high compared to earth fill. Okay, this is typical cross-section of embankment dam. You can see just the reservoir is filling with upstream flare width dimension and downstream slope also. You have downstream passive wedge resistance and also hard rock strata below the foundation. So you have, this is typical cross-section of concrete gravity dam. So just to show you. Otherwise, we will see in chapter 2 the detail of stability analysis. So these are also additional just sample for concrete dams. You can see with navigation log and other ancillary structures. You can see it's also a gravity dam with spillway, and this is buttress dam, and this is arc dam or arch dam. So you will just see the detail in chapter 2. Okay, next topic is site investigation, selection of sites, and type of dam. So how do you investigate? How do you investigate dam site? So the first step is, what is the purpose of site investigation in the context of dam engineering? The first one is to determine the suitability of the selected site for dam construction and reservoir storage. So the first one is suitability. Is it suitable for dam construction or reservoir storage? You will go to the site, then by visual inspection, you can just recheck it. And to describe the geotechnical parameters necessary for the design and construction of the structures. So geotechnical parameters also you have to describe. Otherwise, it may be difficult during construction. So this is the first step for site investigation. Then a dam and reservoir site must satisfy certain functional and technical requirements. So any dam or any reservoir should fulfill functional and technical requirement. When we say functional, it will be governed by the balance between its natural physical characteristics and the purpose of the dam and reservoir or reservoir. So see just a balance between natural physical characteristics and the purpose of dam and or reservoir. For what purpose you are going to construct. So this is functionality, and the technical associated to the presence or absence of suitable site for a dam, and also material of construction and integrity of reservoir basin. Integrity, is it integrate, well integrate? Integrity of reservoir basin with respect to leakage. So this is technical. So technical requirement and functional must be fulfilled. So these are the main principal determinants for establishing the technical suitability of a reservoir site. So the first one is hydrological, geological, or geotechnical characteristics of the catchment and also the site, the specific site. So you should just complete hydrology, geology, and also meteorological data and topographical data, etc. must be checked. So these are the principal determinants for the technical suitability of a reservoir site. Hydrology, geotechnical, geology, and also meteorology and topography also you have to have. So critical aspects in the analysis and design process that require coordination in dam or reservoir sites. These are the main critical aspects in the analysis and design process that require coordination in dam or reservoir site. The first one is preliminary assessment of geological data. You need to have geological data, subsurface condition, and rock structure. So these are the main issue, preliminary condition. And evaluation of technical and economic feasibility of alternative type of structures. So alternative type of structures also, you should consider the economic feasibility, whether it is feasible or not. And selection of material properties, design parameters, loading condition, loading effect, potential mechanism, or other related features, analytic models also must be checked. And also constructability reviews to see whether design assumption and construction procedures are compatible. So constructability review just to see whether the design assumption and construction procedure are compatible. So you need to have constructability review. And the last one, refinement of the preliminary structure configuration to reflect the results of detailed site exploration, materials availability, and also laboratory testing and numerical analysis also. You have to check refinement of the preliminary structure. And the other one is cofferdam and diversion layout design and sequencing requirement also must be checked. Cofferdam and diversion layout. So cofferdam, you may provide upstream and downstream cofferdam. Otherwise, flood may come. You have to provide upstream and downstream cofferdam. Size and type of outlet works and spillway also. This is also another critical aspect. So these are the main issues. And collection of data, just you have to collect data on the site. Physical and topographical data, for example, valley form. What type of valley you have? U-shape, V-shape, or wide channel, wide river, etc. You have to check. And the slope of the valley, the slope of the river, general plan, general layout of the site. So you need to have just enough data collection on these aspects. And also geological and geotechnical and geological data also you should check. Either dam, spillway site, reservoir site, etc. And earthquake also. Earthquake also you have to check whether if the site is suspected to seismic action, then you need to check what you need to check to include in the stability analysis, either horizontal or vertical earthquake acceleration you have to consider. And water resources data must be checked. It could be previous water resource development, maybe upstream dam, groundwater or exploration, etc. You have to check. Project development data also for future, what type of development you are going to accomplish. You have to check. And miscellaneous data also must be considered. General site exploration and investigation, just during site exploration, field investigation is the first one. In situ test, field test, you can collect core sample, just boring on the site, reservoir area. You can bore it, drilling, then you can take core sample. Then you can check in laboratory, just laboratory test also must be conducted. So this is the general project layout. For example, if this is dam structure, then this is upstream side. So flow is coming, then you have to construct cofferdam. This is upstream cofferdam. Then diversion tunnel, you can proceed like this, which is underground. Then construction, you can just accomplish here. So downstream cofferdam also to protect backflow of water to the dam project. You have to provide upstream and downstream cofferdam. This is downstream, then it will join to this one. And the diversion tunnel you have to provide. Then intake, this is intake. Then it could be just underground conveyance. Headrest tunnel you have to provide. Then you have manifold. Then it will be bifurcated or branched to 4 penstocks. So for this specific layout, you have 4 turbines, 4 penstocks. Then finally, tail race tunnel. Then it will join to the river. Then it will go. So you will provide what? You will just provide different access road, etc. overhead transmission line, and also powerhouse, etc. So this is arch dam for layout. And the types of headworks, you have to know the headwork. The construction work done at the river or canal for diversion of water to the off-taking canal is known as headwork. So actually headwork and other outlet works and dam outlet works and also ancillary structures will be treated in hydraulic structure too, I hope. This is just to give you a headwork, what type of headwork you need to consider. Storage headwork or diversion headwork, depending upon purpose, you may provide storage headwork or diversion headwork. Directly it will be diverted, otherwise storing water, then you can use. So the main purpose of diversion headwork is to divert the required quantity of water into the off-taking canal, for irrigation purpose or for water supply purpose or other purpose. You can take out water from diversion headwork. Okay, so this is, I think, the last topic for chapter 1, foundation treatment. So why you treat foundation? Foundation must be treated. If you have weak zone or cavity holes, sink holes, or fracture zones, you need what? To treat these weak zones. So you may have void spaces inside, under the subsurface, below the foundation, or on the abutment. So you need to fill the void spaces so that it will be tight against flow of water. So foundation treatment is a technique of improving the foundation property for the construction of high concrete structures. So you see, just improving the foundation property. How you can improve? You have different types of foundation treatment. The first one is grouting, cut-off, plastic diaphragm. So we will see the detail. So the main purpose of foundation treatment is to reduce what? Seepage and improve the load capacity, the load carrying capacity of the rock. So once you fill the void spaces with these techniques, with this foundation treatment, either grouting or cut-off or plastic diaphragm, you can reduce the leakage or seepage, just flow of water under the subsurface, and also you can improve the load carrying capacity of the rock. So since you just fill the void spaces, then you can improve load carrying capacity of the rock. So let us see the first one, grouting. What is grouting? Grouting is nothing, a process of injecting suitable mixture of water and cement underwater. So you have just hose, pipes, then you just drill a hole, then you can just inject with the pressure. So a process of injecting suitable mixture of water and cement underwater. So this is grouting. And the first objective is to produce effective underground barrier against flow of water. So with this grouting, you are going to fill the void spaces with mixture of water and cement, or sometimes you can add mixture, then you can fill by pressure. Then it will just find weak zone or holes. Then it will fill by this cement and mixture of water. Finally, it will be barrier against flow of water. And to fill the voids in the near surface of the rock under the structure, which in turn increase bearing capacity of the foundation. Already I have said earlier. So you have to fill the void spaces with grouting. So holes will be drilled at some spacing 6 or 4 meter in circular manner. Then you can treat either the foundation or abutment or reservoir area so that seepage will be decreased and void spaces will be filled. So types of grouting, you have different types of grouting. The first one is consolidation grouting. Consolidation grouting. Just consolidation, make consolidated. Holes are drilled to a depth of 3 to 15 meter, which is shallow, and then grouted at low pressure higher than 3.5 kilogram per centimeter square. So with low pressure, you will just grout the foundation property with that mixture of cement and water. Then finally, you are just going to make consolidated so that the settlement will be minimized. So the main purpose of consolidation is to strengthen the rock, creating a strong monolithic slab. Strong monolithic slab. So monolithically bonded together. each layer and also each strata will be monolithically bonded together, so that you will have strong rock formation, and to seal off all major crevices, holes, and cavity zones, and also fracture zones, you can seal off, and to reduce deformability of the rock. So the rock deformability will be minimized. It will not be deformed under the load of the structure, and to increase the modulus of elasticity of the rock also. Modulus of elasticity will be increased. So the second one is blanket grouting. So it is similar to consolidation grouting, except that the purpose of this blanket grouting is to reduce what? Uplift pressures under the structure. So uplift pressure will be to the upward direction under the structure, under the dam body. So you are going to reduce uplift pressure. So grouting is done in front of the dam, upstream of the dam, which is done in the reservoir area of dams. Most of the time, around the reservoir area, you can just fill with this blanket grouting. And the third one is dental treatment. Dental treatment, just excavation of weak zones and dispose it in other place. Simply excavating objectionable materials from solution cavities, fault zones, and filling with concrete. You will fill with concrete. So you excavate weak zone, you remove it, then fill with concrete. So the depth of plug, you can use this equation. Actually, it is empirical. The depth of plug is given by this equation, 0.0066 VH plus 1.5 for H more than or equal to 46. H is height of dam. If it is more than 46, the depth of plug will be this equation. V is the width of the weak zone and H is the dam height. And the second one is you can use this equation 0.3 V plus 1.5 for H, height of dam above general foundation for 6 meters. You will use depth of plug, this one. So H is height of dam above general foundation, above river bed level, and V is width of weak zone. You measure it, then depth of excavation of weak zone below the surface adjoining sound rock. So adjoining sound rock, you just calculate this depth. Then you just enter this pipe, then you will inject with this one. So I think the last one is contact grouting also. Contact grouting, I think this is also just the application is different. Sealing operation intended to bring about a fully bonded contact between any concrete structure and adjacent rock. So you have abutment. It is just rock formation on the side, valley side. Then you are constructing just with a concrete. So this concrete structure and rock, how you can make bonded together. So contact grouting can be applied. So contact grouting is between fully just between rock formation and also between concrete structure and adjacent rock. You can just bond together and use it mostly in the abutment areas on the side, right and left bank of the river, abutment areas of concrete dams, and in the crown areas of concrete lined tunnel in the rock. So for example, underground, you can just make tunnel. This tunnel may be made of steel or cast iron or DCI. So the cavern or the crown is just rock formation. Then you have a steel formation. Then in between, you have to fill with this grouting technique. So just in the crown areas of concrete line tunnel in the rock also, you can apply contact grouting. And the last one is curtain grouting. Curtain grouting, high pressure grouting. Holes may be vertical or inclined. So holes you can make inclined, especially on the abutment left and right side. You can make holes inclined and vertical just below the foundation. You can apply. So purpose of this curtain grouting is to recreate a deep curtain at the head of the dam, which will prevent leakage from reservoir and development of uplift pressure. So this is important curtain grouting. So you have a formula for grouting, for curtain grouting. According to Krieger, for massive rock, you will use this equation 0.23h plus 0.306h times in bracket h over 30 plus 3 square root of h over 11 for massive rock. Otherwise, for sound stratified rock, layer by layer, if you have then 0.23 plus 0.306 times h times in bracket h over 274 plus square root of h over 11. So where P is allowable pressure in kilogram per centimeter square and H is depth below the surface. So this is important formula. So you can just calculate pressure, just pressure for cutting grouting. You will use in kilogram per centimeter square this amount for sound and for sound stratified rock and for massive rock you can use. So maybe for conversion purpose, 1 kilogram per centimeter square is 98.06665 kilonewton per meter square, then which will be converted to kilopascal. So the second method is cutoff. Cutoff, most of the time, an impervious barrier constructed at shallow depths to ensure the water tightness of the dam foundation, water tightness. So cutoff may be provided. Just impervious barrier, just the dam foundation, you can create cutoff. So not only on that, you can provide at some interval, you can provide cutoffs. So it is constructed of rigid RCC structure, reinforced cement concrete. So cutoff is important. And plastic diaphragm, the last foundation treatment, an impervious barrier carried out with plastic structure to accommodate differential settlement. So plastic structure, it is formed from mixture of cement, sand, bentonite, water, etc. You mix them, you can create just as a plastic sheet, you can create impervious barrier against the flow of water. So in conclusion, foundation treatment is done either treatment of rock foundation or treatment of earth foundation. In either case, because flow is going under this. So treatment of rock foundation, for example, final surface of rock foundation and treatment of rock foundation defect. If you have defect rock foundation, then you have to treat with foundation treatment. So leakage through rock foundation, grouting rock foundation, consolidation grouting, drainage of rock foundation could be, and treatment of earth foundation. If you see treatment of earth foundation, the first one is bearing strength of earth foundation. You can increase sliding on earth foundation and also seepage through earth foundation. So if you have this, you have treat your foundation. So I think this is all about the remaining topic. So I think if you have any question, you are welcome. Otherwise, please try these tutorial problems. I think already uploaded in your e-learning. So you can already, I have provided you with USB flash, this soft copy. So please try just theoretical problems. So I think we will do this as example. We will do this capacity, calculate the capacity of reservoir using trapezoidal and cone formula. I think as a tutorial, we will do this exercise. So the rest, please try. Try this tutorial problem for chapter 1, already given with hard copy and soft copy to you. So please try. If you have any question, you are welcome. Otherwise, we will continue to tutorial in the next session. Thank you. And thanks for watching this video. So this is all about today's lecture. Hopefully you liked the video. If you have any comment or question regarding this topic, please write down in the comment section below. I will reply on it. Please like, share and subscribe this video to get more precise lectures. Thanks.